A great feature of Python that isn't available in every programming language is the ability to slice a collection. Slicing in Python means taking a portion of the collection and using it to create a new object. So let's start by making a list using a list comprehension. So we're going to take the numbers from 0 to 100, actually 0 to 99 of course, we don't include the last number, square them and put those in the list. Let's make sure we got what we think we got. Looks great. So of course we can access the individual items of this list using the index operator, which is the square brackets. If we want item number 2, which is a 4, we just put a 2 in the square brackets like this. And there it is. Let's keep the full list around for reference. We can expand upon this index operator using slices. So if we want, for instance, the first 10 items, we could go from items 0 to 10. This is called a slice, and the first number represents the start position, the second number represents the stop position. Just like the range function, this slice will stop just before it gets to the position number 10. So this will list the items from index 0 to 9, 10 items, but stop before we get to item number 10. Let's see what we get. So here's our original list, and here are items 0 through 9. Perfect. There's a third position in the slice called a step. Just like range, we could step by 2s. And in this case, we'll still travel from 0 to 9, but we're only going to hit the even indexes. So we'll hit 0, 2, 4, 6, and 8. Here's position 0, position 2, position 4, position 6, and position 8. What's pretty cool is that we can also slice backwards. So if we start with 10, and go down to 0 and step -1, then we travel down the list backwards from item 10 all the way down to, we never get to 0 of course, so we should end with 1. Let's see. 10 squared is 100, so this must be the element in index 10. And we go backwards with all the perfect squares down to 1. We never hit 0, because 0 is the stop position, and we don't get to the stop position. If we really want 0, we can't put -1 here. We'll see why in a second. We could leave this blank. Blank means go all the way to the end of the list. There we are. Incidentally, we can use blank in the forward direction too. So suppose we want to go from position 90 all the way up to the end of the list. We just do 90, blank, and there's our result. You might be surprised that 10,000 isn't the end of the list, but remember, our range really only went up to 99. If we leave both items blank, we're saying we want to go from the start of the list to the end of the list. Now these two objects look identical. They both contain the same numbers, but if we print out the ID of each one, we'll find out they're different. And that turns out to be super useful because it's an easy way to make a shallow copy of a list. We can say new list equals my list and use a slice with no start or stop position, and we'll find that new list and my list are not the same list. We can change one without affecting the other. We can use slicing with tuples as well. Negative numbers in both tuples and lists start from the end of the object, just like they did for indices. So if we want the last 3 numbers, we could say my tuple -1 to -4. -1 is the last item. We said we wanted 3 numbers, so we're going to have to go to -4 because we never actually hit the stop number. And we're indexing backwards in this case, so we're going to throw in another -1. That's why we couldn't use -1 for a stop position when we wanted to go all the way to the beginning of the object, because -1 always refers to the last item. Remember that tuples are immutable, so if we use slicing to make a new tuple, Python isn't tricked. It just makes another name referring to the same tuple. But if we slice just a portion of my tuple, of course that's a different object. So we get 2 different IDs. If you want to extract a portion of a tuple or a list, you can use a for loop. but the cool Python kids use slicing. The results are the same, of course, but this is not Pythonic.